Next, we will look at what affects software engineering productivity. So far, we have talked about software engineering. Now, we introduce an additional concept and start talking about empirical software. We have learned that software engineering is about increasing productivity. We understand that this productivity can be understood through concepts of faster, better, and cheaper. When we talk about empirical software engineering, we mean that our knowledge about software engineering is derived from observation or experimentation. In the words of this great fellow, Deming, we can say, "In God we trust, all others must bring data." Deming was an engineer and a statistician. He was one of the founding fathers of statistic-driven product development, or as we would now say, using data analytics in product development. Following from Deming, empirical means being data-driven. This data may come from experimentation, observation, or statistical sampling. Finally, empirical software engineering is a broad topic, ranging from human psychology to advances in technical topics like developing the best possible programming language. The reason for this broadness is the fact that the very large variety of factors affect software engineering productivity. In this slide, there is a lecture exercise. Your task is to find the top productivity factor. Productivity factors are given on right, and they are programming practices, software tools, personnel and team capability, and requirements volatility. On the left, you can see how big factors each of these has on productivity. So for example, on the left, the value of 1 would mean that the factor has no positive nor negative impact on software productivity. Value of 4, on the other hand, would mean that productivity is increased by 300%. I suggest you pause this video now and try to think what would be the top productivity factor. The answer to the lecture question of the previous slide can be seen here. We can find that personnel and team capability is the biggest productivity factor. This is followed by programming practices, requirements volatility, and software tools. However, you can also see that the differences between programming practices, requirements volatility, and software tools are not so big, whereas personnel and team capability is clearly much larger than any of the 3 previously mentioned factors. You can also see the source for this finding. Here we can see 3 group classification of software productivity factors. We can have advances in software engineering classified as technology, process, or people. From the 4 previously mentioned productivity factors, software tools can be classified to the technology group. Requirements volatility and programming practices can be classified under the process, while personnel and team capability clearly belongs to the people group. Here we can see more examples of factors that may or may not increase software productivity. Under people, productivity can be boosted by educating people. Also, motivating people can be really helpful. And of course, simply hiring more talented people would increase productivity in software engineering. Under software process, we can try one of the following. We can use standard programming practices. We may allow no late changes to software requirements. Or we can have a separate team of testers to assure the quality. Under technology, the following examples could be helpful. Object-oriented languages like C++ can have higher productivity than procedural programming languages like C. We may think that Git version control is superior to SVN version control. And we can consider that NoSQL databases are better than SQL databases in storing video content. What is shown in these slides are simply examples of things that could help. This is by no means a thorough list, but it may help you in reflecting and thinking about factors that can boost software engineering productivity.